So in that sense, the next speaker will talk about generative AI-powered security with digital threads, and this is going to be David Melamed, CTO and co-founder of JIT. Please, David.
Okay, hello, everyone, and thank you for staying for the last talk of the day. And I know that I'm conscious that I'm actually the only thing that separates you from the coffee and the food outside, so hopefully it will be interesting enough. A little bit about myself. I'm David Melamed, co-founder and CTO at JIT. I'm also actually a doctor, though I didn't put it here. I have a PhD in bioinformatics, and I live and breathe automation technology. What I want to talk to you about it today is like GenAI-powered security with digital threads. Does anyone have a clue what a digital thread is? No one, and that's great because that was expected. Not a lot of people know about that. Just a word about actually what I'm doing in JIT, the company that I created 4 years ago. We're doing DevSecOps, meaning that we help all the companies around that are creating softwares and deploying that to the cloud to protect their code, their infrastructure, everything around the product. And so you'll see in a minute why it's actually really relevant to the topic that I want to talk to you about. So a long time ago, probably before most of you were born, manufacturing was done in a very different way. And basically a lot of things were manual. There were big chains where people were working, and everyone was responsible for a part of the chain. And the thing was that at the end, when you put everything together, you could get great products, and the head of the chain actually got most of the credit. The problem with those chains was what happened when there's a defect in the chain. Everyone was responsible of some part of it, but what happened if something happened and you need to fix something? Who actually owns the fix? So a little bit further down the road, when you're looking at digitalization, things are working very differently. And now we actually found a way to fix this issue by connecting all the dots from multiple silos of data into something that is like a knowledge graph that includes all the data together. And so now it's really easier to find actually what's the source of the defect and also who can be responsible for it. So there's really a big difference and big innovation in the sense that now, thanks to connecting the dots, when you have multiple silos of information that are disconnected, you can actually fix anything inside a chain. Now, if we're looking at how we're building software today, we have kind of the same problem. Usually, if you're building a product and you're deploying that to the cloud, you have multiple points of data, but that are disconnected one from the other. So you have on one hand, like the developer that is working on code, and then you have a process where you're taking the code and you're building some artifact, and then the artifact is deployed in the cloud. And all these different steps in the process are actually disconnected one to the other. And so the problem is, if there's a defect inside this chain, what happens, and basically, how can we find what's the source of the issue and who should be responsible to fix it? So based on that, we took the idea of this digital thread and we thought about connecting all the dots together. So here's just an illustration of what you could do by just putting a lot of different units inside a company together. And the idea is that if you can really link the data from the code to the cloud, then you have a lot of information that can be used in order to understand how the product is working, how the product is built. And from that, you can get many ways to actually fix like defects here in the software. So if we're thinking about security and cybersecurity, one of the challenges is that usually, and especially in the world of DevSecOps and application security, is that tools are generating a lot of false positives. The problem is that when you're thinking about scanning some code and looking for only patterns inside the code, you can generate a lot of output, but it's not necessarily relevant at the end and doesn't necessarily need to be fixed because it doesn't have any context. Now, in order to get context from any security tool, you need to actually have more data. And by connecting a lot of the points together from code to cloud, you can get access to this data. So this is an example of how you can build a knowledge graph for building any software out there by connecting all the repos, all the repositories where the code is stored, the ownership of the teams that are working on those repos, the process of deploying this part of the code to the cloud, until the runtime when everything runs. There are major advantages of building this graph. One of them being, for example, being able to tell everyone, okay, this code is actually deployed to the cloud, and this has access to customer data in production, versus this other repository is not that important because it's only deployed internally into the company for, let's say, a back office tool. And so by being able to differentiate that, you can actually prioritize the things that you need to fix inside the company in order to focus on really what matters for the business and not being distracted by all the false positives that all the tools can generate. This is just an example of how this knowledge graph can look like from the code here at the left to the cloud and actually how it's deployed in the internet. So the only problem with this approach is actually how do you query the graph? So of course you could get a list of all the risk that this graph is generating and then doing that manually, but we're in 2024, and so it's very interesting to look at the capabilities of LLM and using GenAI, because GenAI can very simply generate queries and also return back some data that is actually human readable. So this is what we did at JIT. And so the first thing that we did is to build the graph in order to be able to reduce the risk of the product for all our customers and to make sure that the teams are only focusing on what really needs to be fixed and maintain their velocity. Why did we try to combine actually knowledge graph and LLM? That's a really interesting story, is that if you're taking the advantage, there's pros and cons for each of the approaches, like just using knowledge graph and just using LLM. By combining both of them, you actually get the best of both worlds. For example, if you know about hallucinations for GenAI, if you can limit and add boundaries to the model by just telling the LLM that it needs to only generate queries based on a schema that you're sending it to him, then you actually limit a lot the hallucinations that can happen. So this is just like a summary of both advantages that you can get when you're combining both knowledge graph and LLM. And there are actually a lot of research that are supporting that, and a lot of interest right now in the community on how to combine both knowledge graph and LLM and how you can get out of it in terms of accuracy. This is like, I built a demo that I won't be able to show it now, but for anyone that is interested, I can show you that in the coffee on my laptop. So basically, the idea is that I wanted to put a simple demo where you can actually ask a question to this orchestration engine that is using an LLM behind the scenes. It actually generates, based on the question that you ask, it generates a query, knows how to query the graph, and then returns a response in human language. This is like the general flow, and this is how it was implemented using different technology, like some technology from AWS and some open source libraries like LangChain. I also tested this architecture with different models, and actually it's very interesting to see the difference between the accuracy of each of the models. So first of all, if you want to really play with that at home, you can. This is a public repo that I added. So all the instructions to play with it are there if you want to see it live in the coffee. But what I did here is that I took some sample data that AWS is providing into one of their repositories in one of the notebooks that comes with the Neptune, which is the graph database that AWS supports. And using some sample data, I could show in this simple application how you can query things like how many machines are currently running in the environment, or is there any machines with a public IP? These are the type of the questions that are converted by GenAI in queries to the graph. It asks the graph graph responds with a JSON with some data, and it's translated back by the model into something that is like human readable. So this is something really great that we implemented ourselves. This is also a quick view of the architecture, how it works. I just want to show you like what we did internally in our product and like the results that we got. So from the thousands of vulnerabilities that were generated by all the tools that we ran into some environment, we actually could focus on 3 to 6% of all the vulnerabilities by just using this method, creating a graph, and being able to leverage the graph and the risks that are generated from the graph in order to find which vulnerabilities are interesting. So this is definitely something that is cutting edge, and there will be more things around that in the future. Do you have any question? Yeah, on the coffee. In the coffee, I'll show a demo on my laptop for sure. Thank you very much.